Hi, my name is Olli. I'm the product manager for OZO Player SDK. In this video, we are going to go through one of the sample applications built in the OZO Player SDK to see how you can build your application flow and use the interfaces provided. The fastest way to get started building your own 360-degree video experiences with OZO Player SDK is to start from the samples and reference application. The reference application is a full-fledged player app with UI and controls. The sample application is a very basic example app for just playing back a video. We will walk through one sample using Windows. The other samples follow roughly the same overall structure with platform-specific changes. To create the SDK instance, we fill the platform parameter struct with Windows-specific parameters, which are window handle and install handle. Also, we provide analytics parameters with the selectable license ID. And we need to specify the graphics API to use. On Windows, we support OpenGL. On mobile platforms, OpenGL ES. Then to create the instance of the SDK itself, we provide these three parameters. After creating the instance, we can access the other control interfaces iAudio, iRenderer, and iPlayback controls. In this sample, we are using three different HMD implementations all combined. One of them is the default HMD device, which renders directly on screen. The other two are for Oculus Rift and for HTC Vive. All of the HMD implementations require a handle to the SDK instance, and the default device also requires the window size on which to draw. To initialize the HMD devices, you need to provide HMD parameters which contain the graphics API to use, which should match what was given to the SDK, and the near and far Z-planes for rendering. In the samples, after creating the HMD, we check whether or not the HMD goes to connected state, which signals that it is plugged in and usable. And based on that, we decide which HMD to use. In this example, we are using the direct routing for the audio, so the only thing you need to do is initialize it with direct routing. This makes creating rich, immersive audio playback very simple with our SDK. After that, we load the video using the iPlayback control interface and start the playback. Inside the main loop, we call update on the selected HMD. This updates both the state information and the head orientation information. Here also, if the HMD device is still in connected state, we initialize it. To start the rendering, we first call acquire frame on the HMD device and read the current head transform. Then we give that head transform to the audio playback and we call prepare render frame on the iRenderer interface to start the rendering pass in the SDK. Then we loop through the different eye surfaces in the chosen HMD and pass them to the iRenderer with the render frame method. After looping through, we call finish render frame on the iRenderer to complete the SDK's render pass. If you want to draw any UI or other additional content on the eye surfaces, you should do it here after calling finish render frame, but before calling submit. This is also shown in the full reference applications. After this, we submit the frame from the HMD device to be displayed. Here, if we are using the default HMD, we also have to call swap buffers to trigger the rendering on screen. And that completes the overview of the sample and full cycle of how to use the OZO Player SDK. As you can see, this was all done in a very few lines of code. Regardless of what kind of experiences you wish to design on your application, OZO Player SDK makes it very easy to run the 360-degree video and audio, letting you concentrate on the final experience. Addition to simple sample apps, we also have the full reference application, including full user interface. We have native applications for each supported platform and also a full reference application written with Unity game engine and using the OZO Player SDK through our Unity plugin. The reference application is in the OZO Player App directory. And here you have the OZO Player App.cpp containing application lifecycle handling, SDK and HMD creation, and input event handling, which were not needed in the basic sample application we just went through. The scene directory contains application scenes, also called application views. Splash scene.cpp should be shown on application startup. Menu scene.cpp contains thumbnail grid from which you can select the videos or streams to play. And the player scene.cpp, which is used during video playback to draw video control and user interfaces. Graphics directory contains helper classes related to rendering UI elements. Menu directory contains the implementation for the UI components themselves. And finally, the data directory containing classes related to file listing. As I mentioned earlier, it is probably easiest to get started with the sample application. But if you want to have a look at a full VR experience, the OZO Player app is exactly that. Now that you've created your application, you probably want to publish it. Please refer to the instructions provided by each relevant application store separately. Thank you for watching. Please visit ozo.nokia.com for more resources and to join our online forum. Now it's time to start creating with OZO Player SDK.